Hello, good morning dear students. So in the last class we have finished till question number 3. We were doing exercise 8.4 and now today I'm starting with question number 4. Okay, I'm going with question number 4 part 2. The question is integration log x square divided by x dx. Okay, look at the question properly. Integration log x square divided by x dx. We have to integrate this by using substitution. Now I know the relation between log x and 1 by x, isn't it? I know differentiation of log x is 1 by x. So hence the substitution out here would be let p is equals to log x. Which is this substitution? Let p equals to log x. The moment I substitute, now I know what to do. I'll have to differentiate p with respect to x. So differentiating with respect to x, we will be getting dp by dx, which is equals to 1 by x. Now see what I need out here. I need log x is already p, so this is going to be p square, but dx by x, this dx by x, the value for dx by x I'll be getting from here if I cross multiply with dx. So dx divided by x will be dp. Therefore what is the value for dp? dp is equals to dx by x. So now I can put everything out here in capital I. So therefore capital I becomes, what is log x? Log x is p. So therefore this is p square into, what is the value for dx by dx? dx by x, this is dp. So hence we get integration p square dp. Now we know what to do. So therefore this is this, which is p cube by 3 using the formula. And finally putting the value for p. What is the value for p? Don't forget to put the value for p, the final step. P is equals to log x. So therefore this will be log x whole cube divided by 3 plus c, which is the final answer. So pause the video to note down. Okay, next one we take is question number 5 part 1. Number 5 part 1, the question is integration root over 3 plus log x divided by x dx. Here the integrand is root over 3 plus log x divided by x dx. See, because of this presence of root, now what should we do? Okay, I know differentiation of log x is 1 by x. Differentiation of log x is 1 by x. But I cannot simply take p as log x. There is 3 also. 3 plus log x. Even if I take 3 plus log x as p, 3 is a constant, it will be 0. Differentiation of log x will be 1 by x. So it doesn't matter if I take 3 plus log x also. Okay, but remember 3 plus log x is inside the square root. So whatever there is inside the square root, or whenever there is inside the square root, we have to assume it as p square, isn't it? Which we have done in question number 3 part 2 also. And 1 part 2 also, isn't it? So therefore the substitution here will be let p square equals to 3 plus log x. See, to choose the substitution is very, very important. Whenever it is inside the square root, always the substitution will be p square or some other variable square. Okay, so therefore let us substitute p square is equals to 3 plus log x. Okay, so this whole is p square. The inside the square root, the expression inside the square root, 3 plus log x is p square. Now the next step is to differentiate both the side. So differentiation will give us, we know differentiating with respect to x, this is 2p into dp by dx, which is equals to 1 by x. 3 is 0. Differentiation of log x is 1 by x. Now again here also, if you see this is already p. This is p square, isn't it? So therefore dx by x also we need to find in terms of p. And dx by x will be 2p dp. So therefore the value for 2p into dp is dx by x. So pause the video till here to understand. So I hope you're clear with this step. Now what you need to do, we simply need to put the values out here. So therefore capital I is going to be, this is p square root over p square into dx by x. Dx by x is 2p dp. So everything is in terms of p. Okay, now what happens out here is, this is p square. Square and square root gets cancel out. So therefore I get p into 2p dp. 2 is a constant, it comes outside. P into p square. So 2 into p square dp. So I know how to integrate this, isn't it? So 2 remains as it is. So p square by p cube by 3 plus c. Okay, and therefore this is 2 by 3 into p cube plus c. Now I need to put the value for p, isn't it? By the way, what is my p square? My p square is 3 plus log x. So therefore from here, what is the value for p? P will be root over 3 plus log x. Isn't it or not? Tell me. I hope you're clear. P is equals to root 3 plus log x. So this p we need to put out here. Remember this p cube, so forget about the cube first. Just put the value for p. So the final answer would be capital I, this is capital I, is equal to 2 by 3. What is the value for p? Root 3 plus log x. The value for p is root over 3 plus log x, bracket, whole cube plus c. I hope you're clear with this. So pause the video to note it down. Okay, so that was question number 5, part 1. I hope you're clear how to put the value for p finally, isn't it? So this step is very, very important. Please don't miss this step. So now I move to question number 6, part 1, which is this. So question number 6, part 1, right? So this is the question. The question out here is integration root tan inverse x divided by 1 plus x square. Is there any relation between tan inverse x and 1 by 1 plus x square? Yes, there is a relation. Differentiation of tan inverse x is 1 by 1 plus x square. But again, here also, tan inverse x is inside the square root. So we know what to do. Whenever there is inside the square root, we assume this inside expression as p square. Okay, that is this. So let p square equals to tan inverse x. And differentiate it, you'll get 2p into dp by dx. Differentiation of tan inverse x 1 by 1 plus x square. Cross multiply with dx. So we get the value for dx by 1 by 1 plus x square, isn't it not? That is 2p dp. Now the things are similar, same as the previous question. Therefore, capital I becomes root over p square, isn't it? Root over the value for tan inverse x. Root over p square into the value for dx by this is 2p dp. Square square, it gets cancelled out, isn't it not? It gets cancelled out. So there's p only. 2 is a constant. It comes outside. P into p square. So differentiate it. You'll get 2p cubed by 3 plus c. That is this. Finally, what is the value for p again from here? P is equals to root over tan inverse x. Remember, there's whole cube. The value for p is root tan inverse x. There's whole cube. So this will be root tan inverse x whole to the power 3. That is this. So pause the video to note it down. Right, this is question number 7. The question is integration sin x into cos to the power 5x dx. Again, here I cannot integrate directly. We have to use some properties out here, okay, and some relation we need to know. We obviously know the relation. See, if I assume p, this is cos to the power 5. If I assume cos x as p, I know differentiation of cos x is sin x. Okay, so hence, assuming cos x as p. So we cannot take p as sin x, because p is sin x, I will not be getting cos x dx. This is cos to the power 5, no? So there will be a problem, okay? So if I take cos x as p, then it will be easy for us. So let us assume p as cos x. So p as cos x, so differentiation is minus sin x, so dp by dx will be this, okay? I need to find the value for sin x into dx. This is p to the power 5 according to assumption. So I need to find the value for sin x into dx. So sin x into dx will be minus dp. Minus comes this side. Okay, this is this. So putting the values, we get capital I is equals to, say this was cos to the power 5x into sin x dx, right? So what is the value for p? Cos x. So this, is it p to the power 5? And what is the value for sin x dx? Minus dp. So everything is in terms of p now, which is this, cos x, p to the power 5, p to the power 5 into the value for sin x dx, minus dp, minus sign comes outside. This is this, minus integration p to the power 5. Now we know what to do, p to the power 6 by 6. Okay, this is the step. So therefore, finally putting the value for p as cos x, what will I get? Minus cos x to the power 6 divided by 6 plus c. So I want you all to pause the video to note it down and understand. So I think so now so far you have got the idea how to proceed with the sums now. Okay, so now we move to question number 9 part 1 quickly. Integration root tan x 1 plus tan square x into dx. Now I know the first thing, 1 plus tan square x, can it be simplified? 1 plus tan square x, it is sec square x, isn't it or not? Using the formula. So this is the first step, sec square x. This is sec square x dx. Everything is same. Now I know the relation between tan and sec square, isn't it? Differentiation of tan x is sec square x. It is inside the square root. What to do? So put it as p square. So let p square equals to tan x. The same things again. Differentiate. You'll get 2p into dp by dx equals to sec square x. That is this. What you need now from here. See, this is already p square. Now the value for this is what? This is 2p dp, isn't it? That is this 2p dp is equal to sec square x into dx. Now it's easy for us just to put the value. This was the question. This was the question. Therefore integration root over p square into 2p dp. Now p square and square root gets cancel out. Okay, 2 is a constant, bring it outside. That is this. So integration this of p square means 2 into p cube by 3 plus c. Now finally, what is the value for p again from here? P square equals to tan x. So what is the value for p? Root over tan x, no? So this value for p we need to put back out here in the final step, which is this. This is p to the power 3, but the value for p is root tan x. So root tan x all to the power 3 plus c. So pause the video to note it down. Okay, look at this question number 11, part 1, and then pause the video and try to think yourself what would be the substitution. Denominator is root over x minus cos x, numerator is 1 plus sin x. Pause the video for a while and then think. If you see the relation x minus cos x, if you substitute p as x minus cos x, what do you get? Differentiation of x is 1 and differentiation of cos x is minus sin x. So minus and minus will be plus. So I'll be getting 1 plus sin x, isn't it? So if I substitute this expression as p, I'm getting the numerator. But this expression is inside the square root. So what should I do? Not only p, I should substitute as p square, which is this. So on p square, you'll get this. This is your p square. Okay, so differentiate with respect to x. 2p dp by dx is equals to 1 plus sin x. So 2p dp by dx is 1 plus sin x. You cross multiply with dx. So therefore we get 1 plus sin x in a dx is equals to 2p dp. That is this. Isn't it or not? So the next step is easy now. We got everything. So therefore capital I will be this. You verify, capital I is integration. The value for 1 plus sin x dx is 2p dp. 2p dp. Denominator p square root p square. So what gets cancelled out? Square and square root gets cancelled out. So the next step will be this. 2 p by p. Here p and p also gets cancelled out. So it is only integration dp. So integration dp means integration of dp means p. So 2p plus c. And what is the value for p? The value for p is from here root over x minus cos x. So pause the video to note it down. So we move to the last question of the day. That is question number 12, part 2. Right? So 12 part 2 is a bit lengthy question because we need to substitute twice out here. Not only for, in a single substitution we will not be getting the answer. We'll have to substitute twice. Okay? Let's see how. So this is the question given to us, which is a very huge expression. You can see out here there's tan, there's sec, okay, denominator. We don't have a direct formula to integrate this type of integrals, isn't it? But we can always substitute. Let us see what is the relations given out here. See, if I substitute tan x equals to p, easily I'll be getting sec square x. Without any doubt, you substitute p equals to tan x, it'll be sec square x, isn't it? So that is the first substitution. So on doing so, we will be getting this step. You verify yourself. P equals to tan x. Please follow my instructions properly. P equals to tan x. Differentiate with respect to x. We get dp by dx is equals to sec square x. So therefore dp is equals to sec square x into dx. I hope you are clear with this part. So therefore sec square x into dx, I got it as dp. Everything will be in terms of p. Let us see how. So therefore capital I becomes this. Let us see how. P equals to tan x. So therefore this will be p is equals to tan x equals to p. So therefore this will be 3p square plus 2. 3p square plus 2 divided by p cube plus 2p plus 5. P cube plus 2p plus 5 whole to the power 2 whole to the power 2 and sec square x into dx. Sec square x into dx is dp. So I hope you are clear with this step. Pause the video to note it down. I hope we are clear with this. Just to substitute the values and then we get this. Still we are not getting the simplified form of capital I. I cannot integrate directly. But if I see out here denominators, p cube plus 2p plus 5. If I substitute another variable as denominator, differentiation of p cube is 3p square. Differentiation of 2p is 2 and 5 is a constant. So hence I can again make a substitution out here. So I am substituting this denominator as another variable, say z. So let z be this. So differentiate with respect to now p, not x, differentiate with respect to p now because z equals to p. So I need to differentiate z with respect to p. So dz by dp. So dz by dp will be 3p square plus 2, which is the numerator, isn't it or not? Which is the numerator out here? 3p square plus 2p plus 5. Okay, this is z. So differentiate with respect to p. So dz by dp is this, right? So therefore, cross multiply with dp. That is this, dz. So this whole numerator is dz, and this is z square. So therefore, putting the values, I'll be getting this. Okay, bring a z to the power 2 to the numerator. It becomes z to the power minus 2, which is this. Now we know how to integrate, isn't it? So pause the video. Next page, I'll see how to integrate. Alright, on integration you get z to the power minus 2 plus 1 divided by minus 2 plus 1. So all these calculations you know how to do. Bring it down. 1 by z. Now, finally we need to put the value for z. So what was the value for z? 3p square plus 2p plus 5, isn't it? So let's put the value out here. P cube plus 2p plus 5. Sorry, what was the value for z? P cube plus 2p plus 5. So put the value for z. Again, the question was in x. So answer also has to be in terms of x, isn't it? So what is the first substitution of p? P was tan x, isn't it? So hence put the values out here. This will be tan x whole cube plus 2 tan x plus 5. Okay, curly bracket and minus sign plus c. So pause the video to note it down. Right, so this is the final answer. Important question. We are doing 2 times substitutions out here. So please note this type of questions properly. So that was the last question, and your assignments for today is this exercise questions. 5 part 2, 6 part 2, 9 part 1, 11 part 1, 12 part 1 and 14 part 1, which are very, very similar to all the questions that you have done just now. Okay, so that's it for today. So we'll see tomorrow then. We'll continue with the exercise. Take care.